Welcome back to the deep dive. Today, we're boarding the technological equivalent of the Apollo mission. We're going deep into artificial general intelligence, or AGI.
And this isn't about, the chatbots or the recommendation engines that you use every day.
No, not at all. We are talking about creating systems that are capable of true, generalized, human-level reasoning across every single intellectual task.
It's the inflection point that, everyone has been anticipating. It's moving so rapidly from science fiction to, engineering reality.
It really is. And we've been studying a stack of sources focusing heavily on research from the Agentics.
Right. They're an AI-powered growth execution company based in Amsterdam, and they've titled their analysis, The Dawn of Human-Level AI, a pretty bold title.
It is. So our mission today is to be your guides through all of this. We need to define exactly what AGI is and how it's so different from what we all currently use.
And analyze the, staggering financial mechanics that are fueling this arms race.
Most critically, we have to look at the radically polarized timelines that experts are projecting for when this hits. We're going to try to cut through the noise so you can be well informed.
So let's start with that fundamental definition. Artificial general intelligence. It's sometimes called strong AI.
Right.
It's designed to be a machine that can understand, learn, and then apply that generalized intelligence across, virtually any intellectual task a human can do.
And that idea of generalization is the real dividing line, isn't it?
It's everything.
Because today's systems, what we call narrow AI, are amazing. They can beat us at chess. They can translate languages instantly.
But they're brittle.
Right.
That chess champion AI can't just suddenly switch gears and, diagnose a rare pediatric disease.
Exactly.
It's a huge distinction. AGI's whole hallmark is its ability to generalize that knowledge and transfer skills between fields that are entirely unrelated.
Right. It sees patterns and principles that cross domains.
Exactly.
Right.
And that allows it to tackle completely novel problems without needing to be reprogrammed. The consensus is that AGI has to replicate the full breadth of human cognition.
Yeah.
We're talking reasoning, planning, creativity.
And a kind of consciousness-like adaptability.
Yes.
So when we talk about AGI achieving, human parity, what's the actual benchmark? Are we talking about replicating a certified genius?
Not at all, which is a kind of a surprising fact for a lot of people.
Right.
The established benchmark is matching the average, unremarkable human adult in versatility. That's the key word.
Versatile.
If you look at the whole spectrum of non-physical white-collar tasks, logistics, creative writing, medical review, a competent AGI should be able to outperform, say, 50% of skilled adults.
So the utility isn't its superhuman speed, it's the breadth of its skills.
Precisely. Think of it like having one employee who can run every single department in a major corporation at the same time.
Wow. And that just sets the stage perfectly for why we're seeing these explosive numbers in the financial markets.
Of course. The promise of replacing, or at least complementing, entire workforces.
Yeah.
The financial stakes are just staggering.
The market surge confirms it. It's fueled by massive venture capital and corporate R&D.
And while the AGI sector in 2025 is valued, pretty modestly at about $1.08 billion, the projection is what really shocks you.
Okay, tell us about that projection, because this is where the conversation gets real.
That market size. It's expected to just skyrocket to $11.04 billion by 2032.
Wow.
That's a compound annual growth rate, a KGR of a staggering 39.5%. When a market grows at nearly 40% year over year, it's a technological land rush.
That's a land rush. Every company knows that getting even a tiny lead could mean generational dominance.
And AGI itself is just, one piece of this puzzle. The broader AI market, which is all the infrastructure you need to support AGI, is forecast to hit $2.41 trillion by 2032.
Trillion. We're seeing a feeding frenzy, especially in those adjacent markets.
Oh, absolutely. Take the AI agent submarket. These are the systems that act autonomously for you. That is projected to reach $47 billion by 2030, with an even higher fragile GR of 45%.
Which shows the urgency. We're shifting from tools that just answer our questions to tools that actually do things for us.
The drivers are pretty clear. Cloud-based deployments for scale and immediate applications in high-cost sectors like healthcare, finance, and manufacturing.
And the corporate commitment is just immense. NVIDIA alone is planning $75 billion in AI investments for 2025.
And that money isn't just buying chips, it's buying time and capability.
Which brings us right to the Achilles heel of this whole scale-up.
The energy challenge.
The energy. This expansion is running headlong into a massive constraint on sustainability and infrastructure.
We know a single ChatGPT query uses, what, 10 times the power of a standard Google search?
Right.
So scaling AGI globally with systems that need this continuous intensive training, it's going to put enormous, maybe even unsustainable stress on our energy grids.
That's a huge point. I mean, it can't be brushed aside. If the tech is ready, but the power grid isn't, well, those 2027 timelines become totally irrelevant.
Who pays for that infrastructure upgrade?
Exactly. It moves the discussion from algorithms right into public policy.
Yeah.
Okay, let's switch gears. Let's get into the engine room. How do engineers actually build a machine that can generalize like a person instead of just crunching numbers from a static database?
Well, building AGI requires a blend of neuroscience-inspired architectures and massive-scale machine learning. It isn't just about bigger data sets.
It's about fundamentally changing how the knowledge is processed and stored.
That's it.
So if the holy grail is this generalization and transfer learning, what's the architecture that lets it apply, say, tactical planning from a video game to designing a real-world supply chain?
They're moving towards something called neural symbolic hybrids.
Okay.
Think of deep learning as the system's intuition. It recognizes patterns and associations quickly, like your gut feeling.
And symbolic AI.
That's the rulebook, the logic engine. It manages causal reasoning and verifiable facts. So you combine them, and you get both intuitive pattern recognition and logical rule-based application.
So deep learning sees that two problems look structurally similar.
And symbolic AI makes sure the solution actually follows the laws of physics or logic in the new domain.
That makes perfect sense.
They're also working very intensely on the emulation of human cognition. So not just massive computing, but designing models that mimic our own internal processing.
Like the hybrid models that imitate our fast, intuitive thinking versus our slow, analytical thinking.
System 1 and System 2, exactly.
But what about memory? Because if AGI is supposed to learn continuously, how do you stop it from learning a new skill today and forgetting something crucial it learned last week?
That is the problem of catastrophic forgetting. It's a huge technical hurdle.
And the solution?
To solve it, researchers are building continuous learning mechanisms and nested memory hierarchies. So imagine an AI with both short-term working memory for a task and also this highly structured long-term memory that's constantly being indexed and protected.
Without that, it just couldn't function in the real world.
It couldn't. Despite all this incredible progress, though, current models are still hitting a wall.
We hear about PhD-level reasoning, but that doesn't mean it's AGI.
No. Current models are powerful, but versatility is the bottleneck. GPT-5 hits that PhD-level reasoning in very specific constrained tests.
But
when you test it against versatility metrics, those cognitive tests for human-like breadth, it only scores about 58% toward AGI. It still lacks robust long-term memory and true causal reasoning.
So the future is in those hybrid systems.
It has to be. Just scaling up pre-training, as successful as it's been, is hitting fundamental limits with data and computation.
Okay, let's pivot to the competitive landscape, because the intensity of the last 12 months has just been wild.
Ambitious timelines, major structural shifts. It's been a race.
So who's leading this race, and what are they focusing on?
OpenAI is still the front runner. They have a very aggressive posture. Sam Altman said back in January 2025, we are now confident we know how to build AGI.
And they've backed that up with releases. O3, the reasoning model, and then GPT-5 in August 2025.
Which confirmed those PhD-level reasoning benchmarks, yes.
But the race isn't just about speed, is it? It's about control, alignment. That's where the competitors are trying to differentiate.
Absolutely. DeepMind's Gemini 2.0 Flash thinking model is all about advancing thoughtful reasoning. And Anthropic's Claude Opus 4 upgrade focuses on policy analysis and reliability.
And that safety focus is getting more explicit.
It is. Anthropic is piloting a system they call Decepticon.
Which sounds like something out of a comic book.
It does, but it's very serious. It's designed for deception testing. They want to predict and counteract any potential misalignments or misuse of their models.
And we can't ignore the high-profile newcomers and splinter groups.
Like Elon Musk's XAI. He's targeting AGI by 2026 with his Grok models promising something smarter than the smartest human.
And then there's Ilya Sutskever. He co-founded OpenAI, then left to launch Safe Superintelligence, SSI.
Which explicitly puts alignment and safety ahead of commercial speed. A very different philosophy.
Beyond the giants, there are smaller ventures pushing the boundaries, right?
For sure. Good AI's Badger architecture, for example, is entirely focused on solving that catastrophic forgetting problem. And we're seeing global competition from state-backed labs in China, the EU's Human Brain Project.
And for the very latest news, just from December 2025, MIT's AI agent can now auto-generate complex 3D CAD models directly from rough sketches.
Which shows that real-world utility is emerging incredibly fast.
But the counter-narrative of risk is right there with it.
Always. Trailer Bits just uncovered new image-based attacks on current models. It reinforces that vulnerabilities are evolving just as fast as the capabilities are.
Okay, let's zoom out for a second and really cement the difference for you, the learner, between the AGI we've been discussing and the narrow AI, the ANI, that dominates, 99% of today's tech?
It comes down to scope, learning, and adaptability. ANI is a single-task specialist, brilliant but brittle. AGI is a multi-domain generalist.
So where ANI is static and needs a human team to retrain it for a new objective.
AGI is continuous, it's self-teaching, it's constantly integrating new information.
Right. ANI powers your banking fraud detection, but AGI?
AGI could compose a novel by applying literary concepts it first learned by analyzing physics textbooks.
The difference is profound.
It is. ANI needs human oversight for goal setting. AGI pursues complex goals independently.
So given that fundamental difference, the global adoption timeline is the real mystery. How far away is it from changing how we all work?
It's incredibly hazy. The experts are pegging the odds of AGI arriving at 25% by 2027 and 50% by 2031.
Which shows a lot of optimism from inside the development process.
It does, but the median expert forecast, which often reflects more academic caution, still hovers around 2040.
And if AGI does start becoming truly effective by, say, 2026 or 2028, what's the immediate impact for businesses and workers?
In the short term, you'll see domain-specific sort of narrow AGI integrated into highly complex areas. Predictive maintenance for machinery, sophisticated drug discovery, optimizing global supply chains.
And long-term, the socioeconomic impact is monumental.
It's massive. The sources project 92 million existing roles will be lost by 2030.
But at the same time, 170 million new roles will be created.
And that potential job shift is exactly why you're seeing more and more talk about universal basic income, or UBI.
Right. If a machine can do the intellectual work of 500 million people, we need some mechanism to stabilize economies and human welfare during that transition.
But I have to inject some skepticism here. Is that projection of 170 million new roles realistic? Or is that just Silicon Valley optimism?
That is the critical question. The new roles are projected to be in things like AI governance, AI maintenance, and highly creative fields that require collaboration with AGI.
The challenge will be the massive retraining and upskilling needed globally to fill that 170 million gap, to make sure the economic gains are widely distributed.
And this explosive potential is why AGI is hailed as the next big thing. It's not just an incremental improvement.
No, Ray Kurzweil famously sees it as the gateway to the singularity, the point where technological growth becomes uncontrollable and irreversible.
Promising to turbocharge science to solve climate change and cure major diseases.
And the economic optimism is vast. Sam Altman envisions AGI leading to universal high income, and analysts project it could turbocharge global GDP by 14% by 2030.
But the sheer variance in the expert predictions just underscores the radical uncertainty of the time frame. We have a full spectrum, which you need to be aware of.
We absolutely do. The most aggressive forecasts are from those closest to the tech. Sam Altman is targeting AGI by 2025 or 2026.
Elon Musk agrees. He says AGI by 2026 and smarter than the smartest human.
Ray Kurzweil, who has successfully tracked exponential growth for decades, is sticking with his long-standing 2029 prediction.
He sees the accelerating returns of computing power making it inevitable.
Right, and Dario Amodei of Anthropic is a bit more reserved, but still highly aggressive. He's predicting strong AI soon, around 2026 or 2027, as long as safety is maintained.
Even Geoffrey Hinton, the godfather of AI, despite all his cautions, sets his timeline for AGI emergence at 2029.
This whole cluster of predictions from industry heavyweights is in sharp contrast to the general academic view, which the median expert survey. It places the 50% chance of AGI success between 2040 and 2048.
But what's crucial to note there is that even that cautious median forecast has shifted dramatically closer.
It has. It moved up from the 2050s only after models like GPT-4 and ChatGPT arrived. The world is moving faster than even the cautious experts anticipated.
So what does this all mean for you? Well, the technical path to AGI, the hybrid systems, the transfer learning, it's all becoming clearer every month. Transformative AI is coming in the 2030s, and full generalized AGI is much nearer than previously feared.
The core question is shifting from can we build it to when we build it, and whether we can control it. AGI promises a potential utopia, but the stakes are existential. The debate now is all about how we steer this intelligence to uplift rather than disrupt humanity.
This deep dive has shown us that the technological hurdles are being overcome faster than we thought. But the source material explicitly mentions three major non-technical barriers standing in the way of adoption.
Right. Ethical governance, energy infrastructure, and complex regulatory hurdles.
And that gives us the final provocative thought for you to consider as you process all this. When you look at the evidence, which of those three non-technical barriers, ethics, energy, or regulation, will ultimately be the most decisive factor in determining if the optimistic 2027 timeline or the more cautious 2040 forecast wins out?